What if I told you you can learn 10x faster? And this is what I did in med school, and I was able to finish 100 hours of content in just 10 hours while still achieving a perfect GPA. And the secret is this. It's not what you study, instead it's the order in which you study. And this is called the layering method. This is an approach taught by Dr. Justin Sung, who's a world-leading expert in learning, and actually having the opportunity to work alongside him personally, I'm gonna show you what a learning expert uses on the day-to-day to learn any subject at rapid speeds. And also, this is what I use to consult learners as a senior learning coach myself. And at the end of this video, I'll provide a live demonstration of this layering method so you will know exactly how to learn faster using this. So the layering method is all about saying that rather than studying a subject in a straight line from start to finish, we should pass over the information multiple times, with each layer being more and more detailed than the last, so we can gradually build our understanding. And there are typically 4 layers of information when it comes to learning any subject. Layer 1 is like the trunk of the tree. It refers to the most broadest, most foundational pieces of knowledge in a topic. And so you can think of this as the key titles in your textbook. And for example, in this video, I'm going to be talking about studying plant biochemistry. So this could be things like photosynthesis, cellular respiration, photorespiration, and ATP synthesis. Layer 2 are the branches. And this layer covers the main concepts. So for instance, the main stages of photosynthesis, which are the light-dependent reactions, the Calvin cycle, and typically we're looking at this main idea of electron flow, which I'll talk about later. Layer 3 is like the leaves, and this now represents the details. So examples of this could be the reactants, the products of photosynthesis. You're looking at your carbon dioxide, water, glucose, oxygen molecules, rubisco, maybe things like that. And layer 4 is like the random fruits on the tree. And so these are now looking at some of those more arbitrary or smaller details. For example, it could be the name of a specific molecule, like glyceraldehyde 3-phosphate. So just like how we would build a house, we want to start off with the foundations, and then finally we'll do the internal decorations and details at the very end. And with studying, we want to start with understanding layer 1 information first, followed by layers 2, 3, and 4. And that is what the top learners do to speed learn anything. But the problem is this. Our textbooks, our class notes, they are structured in a way where all of the layers of information are mixed together, which makes it far more difficult for us to pick up on these things ourselves. For example, our textbook might look something like this. You can see there's a little bit of layer 1 knowledge here, a bit of layer 2, and then a lot of layer 4. And if we don't rearrange the order ourselves, we end up wasting hours and hours. And we're just trying to understand just what is going on. An example for me is that a lot of the time when I was studying maths in high school, I would always end up working on the hardest questions of, let's say, chapter 1.4, and then I would get completely stuck and waste time there trying to figure it out. Only for me to realize that the very next concept on chapter 1.5 actually explained everything that I needed to know to solve those hardest questions of 1.4. And lots of time was wasted. And this happens all of the time when you learn specifically in order of the textbook or how it's presented to you rather than in these layers. Essentially, you spend a lot of time doing things that you don't need to do. Now, what the layering method allows us to achieve is it allows us to turn something that has all these scattered layers of information into a more structured and organized understanding inside of our brain, which is truly what matters the most. And one of the best ways to physically represent this layering process is by making a mind map. And this is where you have your layer 1 information, branching out into layer 2, then layer 3, and then layer 4, and the arbitrary details that are there at the very end that just need to be memorized. For the details we want to memorize, we just want to use flashcards for that, by the way. So to show you exactly what I'm talking about, I'm going to show you a live demo of me making a mind map using the layering method next up. But speaking of mind maps, I often get asked the question about how do I deal with the fact that writing on an iPad, it feels like a glass and it's quite weird in comparison to writing on paper. And that's definitely the case. And so to answer this question, actually, ever since I've been using iPads, I've always been using Paperlike as well, who are kindly sponsoring this video. If you haven't heard about it yet, Paperlike is a screen protector that makes your iPad feel like paper when you're writing or drawing on it. And what it does is that it uses microbead technology called nanodots to give you that authentic pencil and paper feel, all the while keeping your screen crystal clear, free of glare, and your fingerprints. Now, Paperlike just launched their Note Taker collection, which is the ultimate kit for anyone serious about their iPad productivity. And this all-in-one bundle, it includes Paperlike's flagship screen protector, ergonomic pencil grips, and a versatile cleaning kit to keep your iPad spotless on the go. And here's the best part. You'll save 15% when you buy the Note Taker collection compared to getting each product separately. If you want to level up your learning like millions of students worldwide, click the first link in the description to check it out right now. And with Paperlike's 100-day satisfaction guarantee, it's just a no-brainer. And so now I'm going to show you step-by-step on my iPad how I use the layering method for an actual subject. Let's say I have 6 weeks to study biochemistry, and more specifically, photosynthesis and respiration. So step number 1 is to review the learning objectives and other resources such as my textbooks to gauge all of the key concepts that I'm going to need to learn. And this is called the pre-study or priming phase. And the purpose here is to simply just get a list of the key ideas for the topic that you need to study. And for example, here is what I came up with. And you don't need to worry about having every single detail. We can always go back and fill in additional details later on. And stick around till the end because I'll also show you how to use this to specifically cram for exams. Step number 2 is to label each keyword as layer 1, 2, or 3 or 4 information. And you might wonder, how am I supposed to know this if I don't know the content? Well, for any of the keywords that you don't know, quickly Google them or ask ChatGPT to get a rough idea of what they refer to. And you can use your intuition here, right? Concepts like photosynthesis are very broad. And so now we're going to have those as layer 1. And then the products of photosynthesis like glucose or oxygen would be more so like the important details like layer 3. Now, the biggest mistake students make here is that they think they need to have a perfect mind map from the start. But the learning doesn't actually come from the mind map itself. It comes from the process of making the mind map and adjusting it as you learn more. And this is not only possible, but it is actually an expected part of this entire process. So let's go through the list that we had from just before. And now we're going to go ahead and label each keyword with what layer we think it should be. So I've got a list of keywords here now that we were looking at before. And following the criteria that I have for layer 1, 2, 3, and 4, I'm going to start just roughly thinking about where I think these are going to sit. And I can always change my mind later on, which I will definitely be doing as I go ahead and mind map this together. So very quickly, I will say things like for G3P, we've got a number 4 there. NAPDH, I mean, it seems like it's going to be pretty important because I've seen it many times on this textbook. CO2 is probably going to be a 3. Calvin cycle looks like a 2. C3, C4 CAM comes up in the learning objectives all the time. Light-dependent reactions, it's like, oh, maybe that's a 1 or a 2. Photosystem 1 and 2, maybe it's 2 or 3. Photorespiration, definitely a 1 or 2. It sounds like a big concept. Photosynthesis is a 1. Thylakoids, it might be pretty important to understanding photosynthesis. We've got ATP synthesis is a 1 or 2. Oxygen, again, it's an important detail. Rubisco, again, is this how important of a detail is it? Maybe it's even a concept that's at that level. In chlorophyll itself, it's like, okay, yeah, pretty important, but definitely not a concept. So I am basing this off of my very brief understanding of knowing what these words are so far, just from my intuition before even learning very deep kind of biochemistry about photosynthesis. But many of the words that you're going to see for any topic, you're going to have a pretty good guess at what it is. And if not, just check out on ChatGPT what it is as well, and you'll have a pretty good crack at this. So again, these are my first guesses, and they are allowed to be guesses. And so we finally get to step number 3, which is now just mapping out these layers on a visual mind map. And we want to constantly ask ourselves, how does this concept relate to the next? Or how does this layer relate to the next? And essentially what we should notice is that it branches out from these foundational concepts in the center, going out to some of the smaller and smaller details. So let's go through the live demonstration itself now. So we've got all of the big layers here. And as I continue to learn, I'm gonna go to the material. I'm gonna learn more about like, what is photorespiration and photosynthesis? And as I kind of look into it, I'll verify, do I really think this is gonna be one of my layer 1 items? And in this case, I'm definitely going to say that photosynthesis is. So we'll put that down first. So I'm going to scroll out here and we're going to put down photosynthesis, and apologize for my handwriting here. Now, as I was learning about photosynthesis, everyone's talking about it being an opposite of cellular respiration. And that isn't something that is on my original keyword list here, but it is so intertwined and so important based on just my quick investigation that I'm gonna have it as part of my backbone for this mind map. I would say that it is a layer 1 detail at this point. And I know that these are basically opposites, so I'm gonna draw that like so. Now, looking at one of my other 1 and 2s here, I see ATP synthesis. And one thing that I began to understand is that actually both of these processes use ATP synthesis as a key part of how they operate. So I'm actually going to keep that up there as well. For cellular respiration, it makes a little bit more sense because the whole goal of that is that you turn glucose into ATP. But actually from a little bit of a deeper investigation into here, I actually learned that photosynthesis has to create ATP halfway through the process to actually get the end result being glucose as well. Okay, so the next one that I see here is around that light-dependent reactions and the Calvin cycle. I mean, I know that these two things here are key parts of, you got the light-dependent reactions and you got the Calvin cycle, which are key parts of photosynthesis. But as I kind of went into that line of thinking, I was trying to understand, like, how would I group light-dependent reactions and Calvin cycle together, right? Because there's a lot of things that I could say about photosynthesis. Really, these are the stages of photosynthesis. So I could put this underneath the category of stage. I definitely could do that. But I want to always make sure that when I'm doing this mind mapping process, I'm thinking a little bit more critically about truly how is light-dependent reactions and Calvin cycle related. And I think that's a little bit more than just the stages. If I try and really think about what is its function and what is its importance, which is a key thing to think about when you're doing this. And what I came down to by learning a little bit more about these light-dependent reactions and Calvin cycle, asking why is it important and how they relate to each other, I actually understood that the best title that I could go with here is actually electron flow. Now it gets a little bit messy sometimes here, so I'm going to try and rejig this and make this better. So when I clean it up a little bit, it's looking something a little bit like this now. I actually added this little feature here because that helps me remember that ATP synthesis is kind of like this, between cellular respiration and photosynthesis, the same thing is occurring, but just on different sides of this electrochemical gradient, with this being internal and external with either the chlorophyll or the mitochondria. Now, one of the things I also notice is that as I'm diving into this, I see that actually this stuff over here relates with the original stuff over here. And actually I can relate that the light-dependent reactions is where this ATP synthesis is occurring. Another thing, I'm just constantly rejigging it a little bit here in terms of the sizing. I want the key ideas, the layers to stand out in terms of which layer that they are on. So layer 1 needs to be the biggest, needs to stand out there, and then layer 2 and 3 and 4 can be smaller. So if I come back to my list now, I'm looking at my layer 2 details. I want to learn and get deeper into that, asking myself again, why is C3, C4 CAM important? How does that relate to the other stuff that is here? And what I realized is that when I ask how that stuff relates to photosynthesis, I actually found out that it's all to do with this concept and actually key kind of like enzyme kind of known as ribisco. And actually C3, C4, and CAM all have to do specifically with changes with how ribisco is working and functioning. And if I have a little bit more time, I'd actually dive into that and think about, again, is there a better kind of chunk that I could use there instead of just calling it ribisco? But I know that they are very interlinked, and so that's why I'm putting it there. I'm thinking now about like my photorespiration. I've kind of forgotten about that one. As I think about how it relates to particularly these ideas in the backbone, which I'm thinking it will relate to, I actually found out that photosynthesis, a costly thing of it is that it has to have some respiration occurring as well. And that is actually specifically this idea of photorespiration. And so I think it's probably going to be a layer 2 detail, maybe not a layer 1, but I'm going to leave it there for now, and I can always again change this as I continue to learn more. How are we going? We're looking pretty good. Let's add some ticks into here. Okay, so now I'm looking at some of those 3s, those 4s. I see here a photosystem 1 and 2. I know that these are definitely part of how the light-dependent reactions work. So I could, on a smaller kind of level, I could add in the photosystem 1 and 2. So this is ultimately what it might look like in the end. And in creating this video, I was actually studying on a live stream on YouTube, and I created this and talked through this more. But what I'm gonna go through is just talk about some of the key features that you're seeing here so that when you're doing this, you know exactly how to put this together on your own mind map. So first things first is that I created that layer 1 as you saw before, and that is the cellular respiration, the photosynthesis, your ATP synthesis is there kind of as well, and you got a little bit of the photorespiration. I am saying that based on my understanding of the topic, I would like to organize it saying these are the key major fundamental pieces to understanding how this topic works. So that is layer 1. As I go into thinking about now my layer 2, I've kind of got here the Rubisco, electron flow, and the photorespiration. So these are what I think are the important concepts that are not as important as the fundamentals of cellular respiration and photosynthesis. From there, you can kind of see my layer 3 details forming, and then the layer 4 is kind of all throughout. There's all these little things that are all throughout parts of this mind map that kind of are filling in between the gaps. And to reiterate, through this process, I am thinking about, okay, I think this keyword fits into this layer. Let's go ahead and validate that. And I ask myself the 2 questions. Why is this important? And how does this relate to the other ideas that are on this mind map so far? Then I will put it down, see if it makes sense. And if it does, it sticks. If it doesn't, then I move it and put it somewhere else. So that is the process of mind mapping. And this is how you go through it, and you'll get better at this as you practice this. The other part that I want to touch on here is some of the smaller details that you can see that are on here beyond what I've just said. So you can see here, I'm using a little bit of color, making it a little bit more playful with some drawings to help me understand exactly how light absorption relates to electron flow and the thylakoids. And so I am putting down diagrams and drawings here that make sense most to me. This may not make sense to you, but I'm always thinking about how can I best represent this through drawings to also emphasize some of these parts. So I'll tell you what this means. For me, the light absorption, and I have a little bit of a physics background, it is telling me that this is hitting into some of the thylakoids, okay, inside of the chlorophyll, and that allows these light-dependent reactions to occur. And this diagram here is a physics diagram that makes a lot of sense to me, in that it's talking about how when the light hits, that provides energy, right? And that energy is transferred to the electron, and that allows it to jump to a higher level energy state. And when that occurs, this is occurring in photosystem 2, and actually, this electron that is being pushed up, it allows photosystem 1 for the electron again to just go up to another higher level. So you kind of had like the step-by-step process where the electrons have gone up 2 levels. Ultimately, what this means is that there's a lot of potential energy now stored in this electron that is being moved up to the higher levels that can now be used for the reactions required to create the glucose in the end. In reality, the light-dependent reactions are not actually a part of doing all of the hard stuff with the glucose. It's actually about creating some more of those intermediate kind of reactants that are required. So in terms of needing the oxygen, and then also having it so that the NADP becomes the NADPH. And so I add a little bit of details here to just help me kind of like really break things down. So for me, the whole reaction, it's pretty crazy, but really it's all this, is that H2O goes to oxygen, and that's because of the energy that is transferred to the NADP plus to the NADPH. And I've also left a quick note for myself here as a very layer 4 detail, is that it can be cyclic through this process or non-cyclic through this process as well. And then finally, you can see in this layer 4, I just added this small detail of glucose plus oxygen is actually what's occurring when we're doing this photosynthesis step. And actually the glucose comes from 2 G3Ps connecting together through some other reaction pathway. So I understand this is some pretty heavy biochemistry that you learn in your second year of university. I wanted to start with this topic because it's something that people tell me all the time. It's a memorization heavy topic, and therefore, all of us would need to be on flashcards, but that's just not the case. If you actually go ahead and you spend the time to dive deep and understand why a lot of these things work and how they actually relate to one another, rather than just taking things as it is, you'll actually find that you can place this on a mind map and actually have it make very intuitive sense. As you heard me before when I was talking about these electron levels, that is all depicted in just this drawing here, right? That is enough of a reminder for me for that entire process. And I don't need to write this down into words and actually lose all that detail, and it becomes just way too much. 2 caveats with this mind map. Again, I didn't branch out on this part. I didn't branch out from this part. And I would try and refine these in my future stages to really think about, okay, well, how are they actually related to these other parts of my mind map so that I can find a better way of connecting it together rather than just drawing a straight line. So to summarize, learning is this very recursive process. We're asking ourselves time and time again, where do I think this fits in terms of the layers? And then I go ahead, I learn more about it by trying to answer the question of why is this keyword important and how does it relate to the other keywords on my mind map so far. I place it down and I see how it connects. And really you can go through this process of refinement endlessly, but you will naturally notice a point where you're just like, okay, I think I've got enough here. I understand this. And as a bonus point, if you want to learn something really fast or cram, what you need to do is actually focus on layer 1 and then work outward and just focus much more on the layers 1, 2, and 3, and less so on the arbitrary details. You can just cram that in the very last hours and minutes and just load that into your brain just to forget it right after your exam. But the layers 1, 2, and 3 take a little bit more time to understand and properly get. So you need to spend more time there really trying to process it. For every topic, there are thousands of details or leaves, but again, these are usually only going to hang on a few branches. And if you learn those branches, this is just gonna make it much easier. Those details just come far more naturally to you rather than remembering again, glyceraldehyde 3-phosphate. And now that you're able to understand the layering method, you'll also be able to study much faster and create much better mind maps. And this is truly just one of the most powerful study techniques out there, which is why I talk about it so much. So if you want an even more detailed guide on how to make the perfect mind map, then this next video is going to be an absolute goldmine for you. Take care.